All right, so today we are looking at waves a bit more. We are going to be taking a lot of notes today, so make sure that you guys have something out to take notes with, whether that's you take digital notes on your Chromebook or physical notes on a piece of paper. But it is going to be important that you guys know these different terms, some of which you might already know, but a lot of them are going to be actually probably new for you. Now, we haven't taken a lot of notes in this class, so just make sure that you guys are taking notes on these terms because they will come up again and again, and they will come up on tests and quizzes, and I will not be able to help you with what these words mean on tests and quizzes because, of course, that's usually the point of the question, is asking you if you know what these terms mean. All right, so we finished our jigsaw last time, and we're getting into different types of waves. The first is called longitudinal, and the second is called transverse.
Waves transfer energy from one place to another. You should already know how to describe them in terms of frequency, wavelength, and amplitude, which we looked at in another video. In this video, we're going to look at two ways they can be classified. Waves are produced as a result of vibrations and can be classified as transverse or longitudinal. Whether they are transverse or longitudinal depends upon how the particles are made to vibrate as the energy passes. Let's look at longitudinal first. This is where the particles vibrate parallel to the direction in which the wave of energy is traveling. Notice that the ends of the slinky don't ever leave the hands holding them. It's only the energy that travels. The places where the coils or particles are bunched together are called compressions. Where they are furthest apart are called rarefactions. An example of longitudinal waves is sound. When a drum is struck, the drum skin vibrates, which causes the air particles next to it to vibrate. This causes the next air particle to vibrate, then the next, and so on until the vibration reaches the ear, causing the eardrum to vibrate. The vibrating air speeds away from the source, creating a sound wave. Let's look at another type of wave, transverse waves. The hand moves up and down, as does the slinky, but the wave itself moves from left to right. So the particles vibrate at 90 degrees to the direction that the energy is moving. We can simply think of it as, in longitudinal waves, the hand pulses horizontally, pushing and pulling, and the wave energy also moves horizontally, back and forward. Whereas in transverse waves, the hand moves up and down, but the wave energy still moves horizontally. Again, the ends of the slinky never leave the hands holding it. It's just the energy that moves along. Transverse waves are usually used to show the wavelength and amplitude. Pause the video and see if you can remember how to label the amplitude and wavelength on the diagram. Did you get them right? The waves on the surface of water are transverse waves. They make the water surface go up and down. All types of electromagnetic waves, like visible light, are also transverse waves. So, now you should be able to describe the differences between transverse waves and longitudinal waves. Remember, it is the energy and not the slinky itself that travels.
All right, so I know there's a lot of stuff going on there, especially when we get into the two different types of waves. Again, the big takeaway is that the transverse wave, the motion of the particle, is perpendicular or at a right angle to the direction of motion of the wave itself, where longitudinal is in the same direction. Particles and the wave motion is in the same direction. And then we had some labelings for wavelength and amplitude, which we'll talk about more later as well. All right. So again, we're still thinking about our analysis of like what the situation is and what we're trying to deal with. And we realized that in talking into the phone, there's waves that are happening, sound waves. And so we need to know a little bit more about waves. The phone also sends its signal to the cell tower in waves and receives a signal in waves and produces waves. So obviously there's a lot that we need to figure out with regard to waves. Here's a video about the Slinky, kind of, again, trying to show the two different types of waves. Notice that in this case, the hand is moving up and down, but the wave is actually moving to the right. Right? We can see that if we slow it down, or if we just look carefully, we can kind of see that that wave is in fact moving to the right. So that means that it must be a transverse wave. Again, that's because the motion of the hand is different than the motion of the particle. Here's another transverse wave, again showing you the hand moves side to side, but the wave moves from the top of the screen down to the bottom of the screen. Notice that the yellow piece of tape just moves side to side, right? It doesn't move down the Slinky at all. All right. So again, we're trying to kind of understand some characteristics and some terminology that goes with the waves. Now, instead of doing labs or anything like that in person, physically, there's a lot of error that can come up that way. We're going to be looking at some simulations so that we can simplify the whole process down and make it a lot easier to observe and understand. So here's the first part that we're going to have you guys go to, and you just click on this link for wave simulation and then answer the questions on Desmos. And they should be posted in your Google Classroom at this point in time, Tinkering with a Wave. And you guys can open that up and it will allow you to log in and take a look at some of the activities. Each activity is going to have either a section for you guys to answer or some drawings that you'll do on the screen and things like that. So make sure that you guys are reading what you're supposed to be working on and then typing in any answers to any of the questions that come up. And I'll slowly but surely unlock more and more of these slides once we're all kind of on the same page so that we can make sure that we're not blazing ahead too far or anything like that. We'll give about 5 minutes for this first one. Pause the video here so that you can work on that. All right, here is the next one, which is our second slide. Again, from here on, I'm just going to let you guys go for it. I may interrupt every now and again, but for the most part, I'll kind of let you guys work on your own thing. Make sure that you guys are keeping up with where the class is at. If you get stuck or if you have any questions, please let me know.